Greetings, folks. We're going to look at velocity vectors. So I tell you that there is a body whose velocity vector looks like this. When you see something like this, you know how to decode it. You know this information is telling you the rate at which the body is traveling, the magnitude of the velocity. You know this bit of information is telling you the body is moving along the y-axis. It's not moving along the x-axis. It's not moving along the z-axis. And this information is telling you that the body is not moving along the positive y-axis. It's actually moving along the negative y-axis. The point is that if you know how to decode this relationship, it will tell you something about the motion of the body. Rotational motion has the same need. We need to be able to tell people, others, what the rotational motion of a body is doing. And to that end, we need to be able to identify the magnitude of, say, the angular velocity. We need to be able to identify the plane in which the motion is occurring. Is it occurring in this plane versus this plane or that plane? And we need to be able to identify whether or not it's rotating in a clockwise versus counterclockwise direction. And so the question arises, how do we do all of that? The first part is pretty easy. So we just write out how many radians per second the body is sweeping through. The second part requires us to be clever. So I have here my little rotating object. I can have it rotate either way. Kindly note that this body is rotating in the XZ plane. The only point on this object that isn't changing its orientation, and by that I mean this guy is going in that direction, now he's going in that direction, now he's going in that direction. The only point structure on this body that isn't changing its orientation is the direction of the axis. The axis about which this rotation is happening is fixed. It's in the y direction. It's not in the x direction, x direction, not in the z direction, it's in the y direction. So if you and I agree that the way I will let you know what the plane is, the way I will let you know that is by telling you the direction of the axis about which the rotation occurs. If that's our agreement as to our little code, then in this particular case, if the motion that you just saw was what I was trying to characterize here, I would write a j hat next to that magnitude. Because when you would see that j hat, you would think to yourself, the axis about which the rotation is occurring is this way, which means the rotation is in this plane. The axis will be perpendicular to the plane in which the rotation is occurring. What about whether it's clockwise or counterclockwise? Well, that can easily be determined using your right hand. If you just allow your right hand to move with the motion, you will notice that your thumb points in the positive y direction. If it happens to be rotating in the clockwise direction and your hand follows it, your thumb will point in the negative y direction. So you can use positive and negative to convey whether or not the rotation is, as viewed from the positive side of the axis, whether the rotation is counterclockwise, positive j, or clockwise, negative j. The bottom line of all of this is when you see something that looks like this, you should be able to decode it as easily as you can decode something like this. You should be able to look at that and go, ah, magnitude 3 radians per second. Axis about the rotation is y axis, so rotation must be in the xz plane. And is viewed from the positive y side of the coordinate axis. Apparently this thing is moving clockwise. That's it. Have a nice day.